Sarah Schroer, and I'm going to be talking about work I've done with Chen Yu on how multimodal attention creates the visual input for infant word learning. The guiding question behind this research was trying to understand what is the input required for learning a word. Now, learners can take many different forms. You can have a young infant or toddler learning their first languages with their caregivers, or you can have an adult learning an additional language through textbooks and language courses. But you can also have a learner in a human-robot interaction, or even computational models and neural networks that are learning words. But what we see is that across these different learners, infants have this really unique view of the world. And this view supports their word learning, but it also supports the word learning of others. So we've seen that adults learn better when they're taught from an infant's point of view than a third-person camera view. But machine learning models trained with infant data also outperform those same models when they're trained with adult data. And this makes sense when we consider that infants are creating more informative object views than their parents. So here we have the infant's view of the world and then the parent's view of the world at the same moment. And as you can see, that objects are bigger in the infant's field of view, more objects are dominant in their view, and it's just less cluttered overall. And what we see is that in free viewing tasks, when infants are just viewing these types of pictures collected from other infants, we see that infants are only looking at a subset of those objects in the scene, and they're mostly going to be looking at the objects that are big and centered. But the object view is an important part of word learning, but we also need to understand when objects are actually being named. So other work has shown that during successful object labeling moments, or when parents talk about the object that the infant learned the name of, that target object was more likely to be big and centered in the field of view compared to other objects, both during the naming moment as well as in the seconds leading up to and following naming. Other studies have shown that infants are also more likely to be holding the learned object when it was named, if it was learned as compared to a not learned object. And at home, parents are even more likely to label objects when infants are in hand-eye coordination, especially actively manipulating that object. And what we were interested in doing is trying to understand why these moments matter for learning by considering kind of the visual input that infants are getting during labeling moments. So to do this, we had parents and their 12 to 26-month-old infants come into the lab to play with 10 toys that we had assigned labels. And while they were playing, dyads wore these wireless head-mounted eye trackers that allowed us to capture the gaze of the participant, as indicated by that purple crosshair, throughout the time they were playing with one another. But these eye trackers were wireless, which meant that participants could move freely throughout the entire lab space, meaning that this interaction was a lot more naturalistic than if they had to remain seated on the floor. And then after the play session, we used a screen-based task to see whether infants had learned any of those object names. And so our first question was understanding the behaviors of the infant that could predict word learning. So to give you a sense of what this data looks like, I have a short video clip, and this is the infant's point of view, and that purple crosshair indicates where they're looking. And so during this clip, the mom is talking about the kettle and the pot. And at one point she says, "Can you pour the kettle into the pot?" So she's labeling the kettle as well as the pot. But the important thing to know about this infant is that they learned the label for kettle, but not for pot. And so my research is trying to understand the information that's available to the infant so that they can learn the mapping for kettle, but they didn't learn the mapping for pot. So to do this, we identified all of those labeling utterances where parents talked about a learned or not learned object. And we grabbed the infant's visual attention, so what they were looking at, and then what they were holding during the labeling, as well as in the 3 seconds before and the 3 seconds after. And then we defined when infants were in hand-eye coordination, or looking and holding the object at the same time, as well as moments when they were looking but not holding the object and holding without looking at the object. And then we asked for before, during, and after the labeling event, does the proportion of each types of these attention predict learning? And what we saw is that how often parents labeled objects did not predict word learning. Instead, it was the infant's attention surrounding these labeling moments. In particular, hand-eye coordination surrounding the labeling event, specifically before and after, was the strongest predictor of whether an object name was learned. And so our results show that not all infant attention is equal. So compared to only holding or only looking at an object, hand-eye coordination may be creating this learning advantage. And so that was our second set of analyses, trying to understand what this learning advantage might be. So we said that because infants are more likely to learn a label if the object is visually salient during labeling, we would define this learning advantage at the pixel level as the size of the labeled object in the infant's field of view. And then to see how object size differed during successful and unsuccessful labeling events, each utterance was assigned into an attention type category. So either the infant just wasn't attending to the labeled object, or they were only holding it, only looking at it, or in hand-eye coordination. And then throughout the entire utterance, we calculated the mean size of that labeled object, as well as the mean size of all of the distractor objects in view. And we asked, are learned objects bigger during labeling? And what we found is actually learned and not learned objects were the same size during labeling utterances. And more specifically, when we then looked at the size of learned and not learned objects during each types of these attention categories, we also saw that there wasn't any significant difference. But we did notice that there were noticeable differences in the size of the labeled objects across the 4 attention types. So this is where we're seeing the evidence of a learning advantage. So these plots are showing the size of a learned object and a not learned object when they were labeled, and the dot is the mean size of that object throughout the utterance. And then we have it for each type of attention. And we saw when we analyzed just the learned objects and just the not learned objects that the labeled object was bigger than the mean size of distractors in view. So the labeled object is dominant. And we also saw that the size of the target significantly increases across these 4 attention types, which we can see in these plots. However, there was an interaction of these 2 effects. So the difference between the target and the size of the distractor was only significant for when the infant was only holding the object or in hand-eye coordination with the object. Now, I think these plots are informative for seeing how learned and not learned objects differ, but it still doesn't really give us a sense of how the visual input is actually changing with these different types of attention. So to kind of show you these changes, what this top row has is these still frames of these different attention types when the parent was talking about the learned object, in this case, a croc, and then when the parent was talking about a not learned object or the drop. And I just want you to notice how much bigger the object gets across these 4 different types of attention, really showing that this multimodal type of attention and hand-eye coordination is creating this really rich visual information for the infant to learn from. So to conclude, what we see is that successful object labeling is characterized by infants being in hand-eye coordination. And we saw that parents follow and then even extend infants' hand-eye coordination to that labeled object if the infant learns the name. We also saw that hand-eye coordination is producing this higher quality information than the other types of attention. But these are just preliminary analyses. And in fact, we did see a difference in the visual input during successful and unsuccessful labeling events. So to better represent our data in future analyses, we've begun defining attention type at the frame level instead of the utterance level, and we're also considering the visual input before and after labeling events as well. And with these changes, we expect to see differences between learned and not learned objects. But we also think that learning why and how infants create these informative object views can also be used to improve the training sets used in computer vision research. So we're also developing an ideal learner model to test our hypothesis that hand-eye coordination creates this most informative object view. So we're training an object recognition model on the object views created by these infants, and we're comparing the performance when the training set is just frames of no attention versus holding only, looking only, and just hand-eye coordination. So I would like to thank all of you for your attention, and I'd also like to thank our labs and funding sources for their assistance on this project. Thank you.